Hello and welcome to Algebra, Unit 2, Concept 5, Lesson 1. Today's objective is scholars will distinguish between linear and exponential functions. Remember that you should be completing your notes as you go through this video. So let's look at this first situation. My little sister Savannah is 3 years old. She has a piggy bank that she wants to fill. She started with 5 pennies, and each day, when I come home from school, she is excited when I give her 3 pennies that are left over from my lunch money. Use a table, a graph, and an equation to create a mathematical model for the number of pennies in the piggy bank on day N. So, let's look at the information we have. So, we see that she started with 5 pennies, and each day she has 3 pennies. And we're trying to find the amount on day N. So let's look first at making a table. So this is going to be the day. This is going to be the number of pennies. So at the beginning, day 0, how many pennies did she start with? She started with 5 pennies. And then each day she gets 3. So on day 1, she has 8 pennies. Day 2, she has 11 pennies. Day 3, she has 14. Day 4, she has 17. And we keep going. Okay, so there's our table. Let's talk about it as a graph. So for our graph, we know that this is our y-intercept. And I can see that my rate of change is 3 per day, right? So if we look at that as a graph, my y-intercept is up here at 5. So that's the 0.05. And then I'm going to have a line that has a slope of 3. So now how do we write that as an equation? Well, our y-intercept right there. So I have y equals my slope times n, because it's day n, plus the amount we started with, 5. And if I check any numbers for n, I can get the output of the correct number. If I put in 0 for n, I get 5, which shows up here on my graph, or my table. Okay, very simple, right? Let's look at another situation. Our family has a small pool for relaxing in the summer that holds 1,500 gallons of water. I decided to fill the pool for the summer. When I had 5 gallons of water in the pool, I decided that I did not want to stand outside and watch the pool fill. So I had to figure out how long it would take so that I could leave, but come back to turn off the water at the right time. I checked the flow on the house and found out that it was filling the pool at a rate of 2 gallons every minute. Use a table, a graph, and an equation to create a mathematical model for the number of gallons of water in the pool at t minutes. So once again, we are using different formats. So let's look first at doing our table. So I'm going to make a table. It's going to be T is the minutes, and G is going to be gallons. So he started filling it, it had 5 gallons, and so 0 minutes, it had 5 gallons. I see that right here, 5 gallons. So the rate of 2 gallons every minute. So after 1 minute, it would then have 7 gallons. After 2 minutes, it would have 9 gallons. After 3 minutes, it would have 11 gallons, and you keep going on. Okay, well, that's not too bad. There's our table. Next, it asks us for a graph. So once again, I have my y-intercept. Let's look at this part of the graph. You start at 5, and then it's going to keep going up. And it's going to be a line. I have the point 0, 5, and then you have the points 2, 9. Okay, so we have those points on there. Next, when we go to write our equation, we're going to use this, our y-intercept, and we're going to use our rate. We know that the rate was 2 gallons. So I have y equals 2 gallons per minute, plus I started out with 5 gallons. Pretty simple, right? We found our rate of change and our initial value. So let's look at another situation. I'm more sophisticated than my little sister. So I save my money in a bank account that pays me 3% interest on the money in the account at the end of each month. If I take my money out before the end of the month, it doesn't earn any interest for the month. So I started the account with $50 that I got for my birthday. Use a table, a graph, and an equation to create a mathematical model of the amount of money I will have in the account after M months. So once again, we are going to start with our table. I know that I earned 3% interest each month, and I started out with $50. So this is M, my number of months, and this is the amount of money. So month 0, I put in $50. At month 1, I get 3%, which is $1.50 on $50. So I have $51.50. Month 2, remember it's going to give me 3%. So now I need to find out what 3% is of $51.50. And rounded to the nearest penny, that gives me $53.05. And then month 3, again, I'm multiplying times. I'm adding 3%. Now I've got $54.64. And I'll keep going. What would this look like on a graph? Well, change my colors here. So on a graph, I'm just going to be looking at this positive section. I start out at $50, but this is not going to be linear. This is going to increase more and more as time goes up. It's going to give me that exponential curve. Because here I earn $1.50. Here I earn $1.55. Here I earn $1.59. So you see that it's changing by more each time. So now let's talk about how we write the equation for this. We still need that starting value, and we still need our interest rate. So this is going to be our money, which I'll say is Y, is $50 times 1.03. That's my 1 plus 3%. To the m power. So each time, how many times do I multiply times 1.03%? This is my exponential function. And finally, let's look at this last situation. At the end of the summer, I decided to drain the 1,500-gallon swimming pool. I noticed it drains faster when there's more water, which is interesting. So I decided to measure the rate at which it drains. I found it drains at 3% was draining out of the pool every minute. Using a table, a graph, and an equation, create a mathematical model. So let's start with our table again. So this is going to be time, and this can be gallons. So at time 0, it has 1,500 gallons. But then it's losing 3% per minute. So after 1 minute, we're going to do 1,500 times 0.97 because it'll only have 97% left. So at 1 minute, it has 1,455 gallons. And then at 2 minutes, take that and subtract our 3% again. I have 1,411.35 gallons. And at 3 minutes, I have 1,369.0095. And you can see that we are decreasing, but the amount we're decreasing by is changing. It's not the same amount of decrease each time. It's 3%. So what would this graph look like? So if I wanted to do a graph of this, I start up here at like 1,500, and then it trades and gives me that curve. Okay? So then let's look at our equation for it. Our equation, we have 1,500 gallons as our starting point. And then we're going to take away 3%. So I've got 1 minus 3%, 1 minus 0.03 raised to the t minutes, which also can be written as 1,500 times 0.97 to the t. Okay, you notice you get that wonderful exponential curve, but it is decreasing this time. So finally, let's look at the functions that we created for these problems. What similarities do you see? So the first and second problem were linear. They had a constant rate of change. The last two, the third and fourth, were exponential. They had a constant ratio of change. So the difference between having a constant rate, where it's always the same number, and a constant ratio, where it's the same percentage, or the amount, is what we're looking for here. So good luck with your work, and I will talk to you all later.